Hello, everyone. My name is Gilbert. I'm the lead product manager for eBay Data Storage Solutions. I'm here today. I'm going to discuss about object storage at scale at eBay. And so I'm going to go a little bit over the history of object storage at eBay, where we're using object storage, small comparison with other storage, and then drill down into kind of one of the object storage solution that we leverage, and how we were able basically to scale it for our workload and for our business requirements. Okay, before discussing technicalities, just a glimpse of eBay, the company. So we have StubHub, we have eBay Classified Group, and we also have eBay Marketplace under the eBay Inc. umbrella. Our GMV is about 22.6 billion. And we have about 14,000 employees, 182 million active buyers, and 61% of international revenue. In terms of cloud infrastructure, this will give you an idea about kind of, the eBay cloud we're dealing with. We have about 300,000 managed VMs. Also, we have 80,000 managed bare metal, and over 100 petabyte of managed storage. Here, I'm not referring to storage, local storage or anything, that the user can spawn on their compute box. I'm referring basically mainly to managed storage, including block storage, including object storage, etc., etc. Also, we have about 150,000 containers, as well as 5,500 managed application. And we receive around, in the infrastructure, we receive around 400 billion requests a day. Here I'm listing some of the eBay cloud strategies. Pretty much, the full cloud team is focusing on. The first one is kind of, we're fully embracing Kubernetes, getting away from compute to OpenStack. We also have a huge initiative related to designing and leveraging our own servers. And this is basically helping us in terms of optimizations. So we're optimizing the hardware based on the workloads, the specific workloads that we have at eBay, but also it's helping us in terms of cost as well. The third item is related to building our own AI engine. And this is something the AI engine has already accelerated the production of new features such as computer vision, image search, and social sharing. We are fully focusing on building point of presence, and this is targeted towards helping our end users or in order to get faster downloads when using eBay. So by implementing kind of more and more point of presence, we were able to save about 600 to 800 milliseconds of load time for our end users. And the last one part of the big strategy is related to open source transformation. And talking about open source transformation, we're using many open source products, and we're contributing to those products as well, including Envoy, including MongoDB, Docker, Apache Kafka, and Swift. And here, Swift, I'm referring to the Swift object storage, definitely not the programming language. So this is perfect segue, since I'm going to talk now more deeper about kind of the object storage. And so I'll start these slides around there. First, I mean, what is object storage? Object storage, think of it as basically you have the data storage architecture that manages data as objects, as opposed to storage architecture that manages data as blocks or file system. Why object storage is very important? Because one of the main reasons is object storage can scale very, very, very high. So definitely, I mean, when we're discussing about high numbers in petabyte or even exabytes, object storage basically is always highlighted as a great solution for those type of use cases. How the object storage need was identified at eBay. So definitely, as many of you know about the eBay marketplace, the eBay related business, there's a huge data that is needed to be stored, including, I mean, images, including, I mean, content related to buyers, content related to sellers, but also everything, I mean, kind of from the backend system, I mean, related to logs, et cetera, even kind of data that has to be archived, and so on and so forth. So with the need identified, we start looking into various object storage solutions. And talking a little bit about the history around object storage at eBay, the first solution, we call it EPS, which is eBay Picture Service. This one was released in 2007. And this one basically was the solution where, I mean, it stored all images for eBay. So I mean, when you were kind of going to eBay website and kind of the images were being fetched or from this service. In 2008, we introduced EMC Atmos. 2012, we had our own in-house object storage solution called zStore. zStore replaced fully EPS, and zStore hosts all images currently of eBay. And then 2014, we started introducing Swift object storage. And Swift object storage, basically throughout 2017, we were able to replace fully EMC Atmos. And currently, I mean, Swift object storage solution is growing within eBay. And part of my talk, I'm going to discuss mainly kind of about this solution and how we took it further within the company. Why Swift? Why not other? I mean, there are so many object storage solutions available on the market. Swift was chosen in 2014 for several reasons. Some of the reasons I listed them here. The first one is related to high scalability and reliability. The second is about, I mean, it's a pure software-based solution with providing a REST API. The REST API is Swift API, but also, I mean, you can have the S3 API as well. On top of it, Swift is highly elastic. Also, you can provide replication or erasure coding. You can provide multiple policies. I mean, based on the account, a container, et cetera, et cetera. And then also, I mean, Swift is a stateless service. One last important thing I would like to mention is Swift run on heterogeneous hardware. And this is really kind of helping us as we're going into building our own servers. We have kind of specific hardware and kind of, I mean, sometimes it can be a mixture. And we're able to accommodate and leverage those hardware with Swift very easily. Okay, talking a little bit about the deployment diagram. Here I'm referring actually, I mean, to a case where there are 3 replica. So a theoretical case where basically kind of, I mean, there are 3 replica, we're replicating them across multiple data centers. In terms of flow, the end user will be requesting, providing the token, will be requesting from the GTM the Swift endpoint, and the GTM will reply to the end user with the endpoint that is closest to the location of this end user. So in this case, this location, let's say, is data center A, and the end user will be able to upload or download a file, from location A. Here I'm mentioning, this is basically the high-level architecture or deployment diagram, for basically a replication use case. You may ask me, oh, well, if the user is uploading actually a file from or to data center A, how it's going to be in terms of how the replica will be made. So one thing you may want to note is this data center will be responsible of replicating the data on the two other data center. And the way Swift work, or the way you can set it basically is you don't reply back to the end user unless at least basically a quorum has been formed, or more in this case basically. Let's say you have a replica of 3. You can mention that, okay, at least I have basically 2 objects that were saved, or 2 replicas that were saved, and then I return back to the end user. Giving you some statistic into our current Swift object storage solution. So we currently handle about 2 billion objects. We have 2 million containers, 900 accounts, and we receive about 25,000 requests a day. Second, sorry. We have around 5 petabytes of storage currently on Swift. And in terms of bandwidth, is around 30 gigabytes per second. In terms of our customers, who are mainly the Swift object storage customer. Again, what I'm discussing about is a fully internal solution. So our customer are domain teams internal to eBay. But those domain team, provide basically tools or web application or mobile application that are end user facing or public internet facing. So they're using Swift in order basically to have their data stored on it. So some of our customers include Seller Hub. Some of you may be familiar with the feature on eBay. Other customer related, to the deployment. So we use basically Swift part of the deployment process. The third one is related to return shipping label. Fourth is about transaction logging. As I discussed earlier, there is a huge amount of logs, within eBay. So this object storage solution, is used somewhat, for those use cases. We use it also for image search. We use it on PCI, PII related zone or compliance. We use it for Elasticsearch index backup, and also the last one related to zone transfer. About zone transfer, I'll explain a little bit further what I mean by that. And so I'll give a little bit a brief of about how our Swift cluster is connected. It's multi-tenant and multi-zone, and I'll give some background around this. Okay, one thing I mentioned about our Kubernetes initiative earlier, and part of this initiative and part of having or providing object storage, we ensured that Swift object storage solution is working very, very closely with our Kubernetes drive. So, one of the first item we had on the list is we had the eBay container registry, backed by Swift. The other item or part of Kubernetes and Swift object storage is related to we ensure that our customer are able to leverage fully the Swift cluster from Kubernetes solutions, and that their account is created offline seamlessly. Also, we provide for some user who would like to try out basically Swift object storage. In their environment, we provide a Swift running on Kubernetes that they can customize for their own need. Here I'm going to be talking about some of the challenges and solutions that we provided. Again, so Swift is an open source product. We use it, and then we enhance it to our workload. And part of enhancing it, we ensured that we resolve any challenges that are specifically to eBay. The first challenge we encountered and we resolved. A few items I listed here just to summarize or to give some highlight about this challenge. So we're providing what we call a global Swift solution. And think of it as one cluster that is used for all workloads, for multi-tenant and multiple zones. And this cluster is handling a huge number of use cases, of course. We encounter on this cluster definitely a very large number of concurrent access. And also, when we deployed this cluster, we used a firewall, we used a load balancer, and we find out basically our limitation was not Swift object storage itself, because Swift actually can scale, so it can horizontally scale, to clarify. But some of the main bottleneck that we had is related to the LB and firewall that are fronting this solution. So what did we do in order basically to encounter or to resolve some of the problems? One of the first things is we started a program about educating our customer. How they should be using Swift. Many of our customer, or when we started discussing with our customer, they had some notions about object storage, but in order for them to leverage it to the maximum, we had to educate them further and give them some best practices and what they should do, what they should not do, etc., etc. So we find out basically having educational sessions for our customer really helped. In terms of usage, in terms of basically optimizing object storage for their use cases. Also, one thing we worked out on our Swift backend is we split the Swift services. And what I mean by that, I'm not sure if some of you are familiar with Swift, but Swift, there are 4 main components. One is we call proxy. The other is account. Then you have container. Then you have the object. Object is basically the stored data, right? Account container is related to the account. Container is similar to a bucket in AWS. And then proxy, think of it as basically, exactly, like a proxy. It's just basically receiving a request and directing it, to the right account, or getting the right account container and directing it to the right object. So what we did, we separated the proxy or the pack, the proxy account container. We had them on one box. And then we had the object on another type of box. And the box that we used, or the node type that we used for the pack, we call it the pack node for proxy account container. It's a high performance type of node so high on CPU, memory, and having SSDs. And the object node is basically very high on disk storage, but using hard drives or spindles. So think of this node basically in terms of cost is very, very cheap. In terms of cost per terabyte, right? This is very cheap. This is more expensive, but we have only few of the pack nodes. And with this solution, we were able to optimize and to save on cost. So definitely, this turned out to be very good solution. For our use cases. And the last item, basically, that we did, as I was mentioning before, load balancer was one of our bottlenecks. So what we did, instead of just kind of getting more hardware load balancers and it's very expensive, we got into a mode where we're getting basically more software load balancer, and we're able to scale them very easily and kind of on demand sometimes. So this worked out pretty well. The second challenge that we face, and some of you also may face as well. Again, this is an internal solution. So usually there's no kind of dollar amount that are really kind of shared. There's dollar amount at the high level, within kind of budgeting and stuff like this. But in terms, when we discuss with the team and they say, oh, okay, I actually would like to have our workload running on Swift. For them, it's kind of a free offering. And with the free offering, we probably have seen also, you run sometime into many issues in terms of usage, right? Customers start using it. There's a burst number of requests. There's uncontrolled usage. And of course, if the quota is not set, sometimes customer, even though they estimate they're going to be using, let's say, 1 petabyte, they end up, in one day using 2 petabytes or something like this. So what we had to do in order to mitigate that, we had to definitely, provide a full quality of service. So part of the QoS, we had a controlled request per second. So we have usually, an engagement with our customer. We try to understand kind of what they need to do. We try to direct them into the right solution. And then we kind of, depending on their use case, we kind of discuss about certain requests per second limit. And also we discuss about certain throughput that we allow them. If we feel at some point, when they start running, they're kind of, reaching close to this limit, we discuss about them, how either they have to optimize their workload or what we can do on our side, to allow them more and to increase basically the offering to allow more towards for them. And the last thing, of course, we implemented part of Swift is what we call an account quota management. This one we had to be very careful because many of the workloads they start storing objects on Swift, and they sometimes our customer doesn't know kind of how much they have quota left, or so we try basically to monitor that for them, and when they reach a certain limit, we kind of notify them. We work with them about either for them to get approvals for additional quota, or kind of if there's any way for them to clean up their data in order to get within the original storage agreement quota that they had. The third challenge is related mainly to concurrent requests about the same object. And why this is a challenge? Actually, this is a big thing. Especially some of the use case we had when I'm discussing about deployment. Let's say, you have a jar, you want to deploy it into, I don't know, thousands and thousands of VMs. So think about thousands and thousands of VMs. They're having basically GET request almost at the same time. in order to get the object, right? So what you end up basically with the solution that I was describing earlier, especially because your object is on a spindle, right? So you're getting so many requests, and at some point, I mean, the spindle, I mean, cannot handle all of them. Yeah, I mean, at some point, those requests are just timing out, they're failing, et cetera, et cetera. So we had definitely, I mean, to find out a solution for those type of use cases. So what we did, we used what we call varnish cache. Some of you may be familiar with. Also, I mean, we use it kind of, I mean, as an open source solution. So we provided right after, I mean, the software load balancer. So depending on the request, some of them are directed to varnish cache. And if the varnish cache basically is not able to retrieve or does not have the data, it's going to retrieve it from source. So at least in this case, basically, when you have a huge burst of same request, you know, once varnish cache is able to get the data from Swift, it's going to be able to respond with all subsequent requests, I mean, with this data. So this definitely helped. The other thing, I mean, that we work with our customer, depending on the size of the object, is what I call chunking. So let's say, I mean, they have an object size of like 2 gig, 3 gig. I mean, we discussed with them about kind of providing multiple kind of chunks of the same object and assemble them with a manifest. This is not something I'm going to talk in detail in today's session, but I mean, if you guys are interested, there's something in Swift, I mean, called a large object. I mean, there's dynamic large object handling and static large object handling. Swift basically handle anyway maximum of 5 gig. So those strategies are used, I mean, to handle large object, but we were able to use it even on a smaller objects as well. The last challenge is, the challenge number 4 is related to geo availability. And what I mean by that is, I mean, as you know, I mean, eBay is kind of almost worldwide, and we needed to ensure that either from an upload or from a download perspective, I mean, our customers are getting the best performance and are getting basically endpoint, I mean, that are closest to their location as well. And of course, I mean, we had to provide a solution that is very highly available, and also that provide a solution that provides disaster recovery as well. So in this case, I'm going to talk about one of the deployment solution, Replica 3. I mean, what we did in order to provide that. So imagine basically 3 data centers. They're located, I mean, multiple locations, maybe 2 in US, 1 somewhere else. And then what you have, I mean, similar to what I discussed before. So here you have the SLB, you have the cache, the varnish cache, the Swift proxy, which is, I mean, the pack node, and the Swift object. And when a request is received, basically is received kind of by, I mean, the end user sent the request to the GTM. The GTM is going to respond with the closest point. But of course, I mean, here I mentioned Keystone. So we use mainly Keystone for the identity as an identity service. So the end user will have to call Keystone, get a token, which is valid for X number of hours or days. And then basically when the end user have their token, they're able to call Swift and access an object or store an object on it. Challenge number 5, this is the before last challenge I'm going to discuss. So again, multi-tenancy and zone isolation. So multi-tenancy, I mean, think of it as you have basically, I mean, again, we have 900 accounts. So we had to ensure basically all of them works in isolation. But also what I mean by multi-zone, so we have one huge Swift cluster that we call Swift Global, and this Swift Global is provided on staging, is provided on sandbox, is provided on production, is provided on the analytics zone, et cetera, et cetera. So we had to ensure that definitely there's no data breach. only the user who have access to a certain account within a certain zone kind of stay within this zone and stay within this account. So what we did, we implemented basically multiple middleware on top of Swift. And those middleware provided us with the level of isolation that is required, by the business. I'm going to talk briefly about one of them, which is related to the zone isolation. So one of the way, we did that is, from Keystone, we were able to, whenever a user is calling Keystone or the identity service to get a token, we were able to inject the IP address of the user part of the token. But also in Keystone Identity Service, we modified it in order to ensure that Keystone does the validation that the end user who's requesting a token, let's say for production, is already approved and running part of production environment. So we validate the IP against the subnet, a list that basically shared with us, and in order to ensure that this user is allowed to get the token he's requesting. So once the token is created for this end user, Swift receives this token, and Swift again does the validation to ensure that the IP is the same IP that was included in the token. No, it's not like the end user, generated the token from running on one machine, and now he's using it from a different zone, from a different machine. So we validate that. And once we validate this information, we allow the end user to access the account. Of course, we have to do validation on the account level as well. So this is one of the middleware we implemented in eBay to provide zone-related isolation. The last challenge, basically, I'm going to talk about today is related to, think of it about backup and archival. And many of you probably, is facing that. Especially the question, we have data in warm storage. Now, the data, either, need to be in cold storage, or more I know I need to shift a huge amount of data, basically, but I'm going maybe to access it very little, or in the future, just in terms of our archival. So, and for those type of use cases, definitely, you need you need the cheapest solution. You need also high durability. You don't want to lose the data, but also at the same time, you want to make sure, because also, you have a huge amount of data and you're not accessing it much. You're not paying, very high price in terms of storage cost. So Swift was used as one of the solution for those type of use cases. And in order to leverage Swift, so earlier I talked basically about Swift in a replication policy mode. So here we used what we call erasure coding. And so we were able to get 175% less storage overhead with the erasure coding solution policies we provided. And again, so it's still part of the same Swift cluster. Depending on the account or depending on the container, you can say, I want to apply the archival storage policy, and so you're going to get basically the erasure coding applied, or I want to apply, the regular standard high performance policy, and you're going to get basically different type of, more into replication type of solution for your request. Okay, now we talked challenges, we talked solution. The last part of the presentation, I would like to focus a little bit on running Swift. Has been a great experience, but definitely we couldn't done it without of course, the storage team who kind of, helped greatly kind of with those implementation, and running the day-to-day activities on Swift, but also we couldn't do it with the large tooling around monitoring and alerting that the team provided. And this is a key area, actually, in order to run large, high-quality production cluster. I mean, pretty much, I mean, any type of cluster. Here I'm going to discuss briefly about what we use, some of the solutions, we used, for Swift. So definitely ELK, Elasticsearch Kibana. This is one of the key alerting, monitoring solution. We had in place. We implemented that with Prometheus as well. We had our own synthetic tests, so we're doing periodic tests and we're doing validation on ensuring basically the health of the system. We're not only relying on kind of passive monitoring, we're actively ensuring that the system is healthy. We use also Zabbix and all kind of additional type of metrics. So here I'm going to show some of the screenshots. This one probably recognize it. ELK. This one is providing some stats around. The first one, think of it as about. The zone. The second is around the accounts usage, and then you have information about. Each account. You can drill down. You can have each account. Okay, how many containers, etc., etc. Or at a global level, how many containers, how many objects. So you can drill down for each account. And this one is very helpful. As in terms of metrics or kind of informational status, and we have alerting set on this, especially because. When we discuss with our end user and we discuss about their use case, we set a quota for them. And once they are kind of getting close to this quota, we start sending alerts. And so through that, we're able, basically, we have specific alerts in order to that are fired based on the account and based on what we agreed with the end users. The second area, which probably more interesting for you guys, is what I call what's going on the Swift cluster in terms of requests per second. So here we record all the requests that we receive, either GET or PUT, etc., etc. And we analyze the flow, we analyze the usage, the pattern, etc., etc. We also basically do the analysis if there is certain type of errors that are being sent, is either 500x or 400x. If we see an increase in either one, there's alerts and there are basically notification that that we receive. We start checking if there's any issue either on our system, or this is basically kind of benign, someone is doing some test. So we closely monitor and follow up on those. And the last slide, actually, I'm going to talk about. Earlier, I mentioned part of the monitoring and alerting. We have our own active tests. So what we do, we set up automated testing. We upload files, we download them from multiple locations. We have different sizes, etc., etc., and we analyze all of that. Part of this graph. Anything that is basically not specific to the norm, we generate an alert. We start looking into what's going on. If there is any issue on our side, or this is a benign, basically, problem that we're seeing. Great. Thanks a lot, everyone. I would like. I'll be happy to answer any questions if you have.
Wait for the microphone.
Thanks.
Do you see any demand for low latency object storage?
Low latency?
Yeah.
Definitely we have many use cases that are I want to say, in an average latency. So currently, we provide two type of policy. One we call kind of high performance, and the other one we call basically archival. I mean, definitely archival is very low latency. I mean, here. I mean, in terms of, if you think about the high performance, this is something we try to have our SLA within certain millisecond commitment. There has been discussion if we want to kind of provide a third one kind of in between. So let's say, for example, for the high performance, your SLA are kind of smaller than 5 milliseconds or so. I mean, for your archival, maybe they're into the 30 or more, something in between. This hasn't materialized for us yet, but definitely there has been some consideration on that.
What about something that would be like sub-millisecond?
Sub-millisecond. Good question. I mean, this one, I mean, definitely we have some specific use cases that are into this category. Currently, we're not leveraging object stores for them. Yeah, but definitely, I mean, there's a good point in kind of, there has been certain use cases where whenever it's millisecond or under, we're kind of, oh, okay. I mean, definitely it's not on our, I mean, we're not going to handle it right now. Who knows in the future? But definitely there can be.
Okay, you presented 6 challenges.
Yes.
And 6 solutions.
Yes.
Which one of these solutions gave you the best bug for performance?
For performance, basically.
Performance.
You know, I want to say, I mean, 2 things. One is related to the caching, where we implemented basically varnish cache. And the other one is related to the first challenge that I discussed about, related to when we have a huge number of requests and we split down basically the Swift PACO nodes in proxy nodes or PAC nodes and then object nodes. Those provided the best basically performance, I mean, for our end users. Sure.
What's the level of object churn in your environment, and how do you measure it?
Good question. I mean, I don't have, I mean, the data, I mean, with just to make sure. I mean, when you're referring, I mean, object churn kind of, I mean, when you say object basically replacement and
Yeah, well, object store by definition, it's write once, right?
Yeah, exactly.
So object churn, I'm defining as object is no longer needed, so someone's actually executing a delete operation on the object.
Yeah.
And
yeah. So this is a good point. I can explain to you how we handle it currently, and I'll give you some numbers or kind of, I mean, some high level. So currently we have 2 options. I mean, we have what we call a retention program. In Swift, I mean, you can set up basically a delete at. And you can say, oh, I'm uploading an object and I want to delete this object after 3 months. So you could automatically set. Or the other option is basically, I mean, when we work with our end users, they don't know exactly when they want to delete, but always we kind of suggest to them, if they don't know, for them to kind of always assess and work on, okay, I mean, if this object is still in use, and if not, I mean, for them to have kind of, I mean, the deletion apply for it. And this period in terms of, like, I mean, retention, I mean, can vary a lot. I mean, for example, I mean, one area I talked about is PCI, PII. This one, by security audit, we have to keep the data, I mean, within, I mean, we cannot delete it, I mean, within a certain. Other zone, I mean, they have different requirements. And of course, other use cases have different requirements as well.
I might have missed it in the PowerPoint, but where in the system are you executing rate limiting? Is it in the proxy layer, or is it in the...
It's in the middleware.
The load balance?
Middleware, Swift middleware.
Oh, okay.
Yeah. So we implemented our own middleware in order to have the request per second limit. And also we have also the throughput. We have it part of the middleware. I mean, but of course, I mean, this middleware is relying on other system in order to, because think of it, I mean, Swift is stateless, right? So a request can be received by one proxy, but the other request, I mean, by another proxy, et cetera, et cetera. So we had to ensure basically we have the information from all systems.
And that's defined per account?
It's defined per account, yes.
Okay.
Yeah.
Hey, thank you for the talk.
Sure.
I'm more interested to find out your choice of going with Swift as opposed to Ceph, which is another big object storage. And any of these challenges that you listed, does Swift perform better? Is it because of just its integration with OpenStack? What was the decision?
Absolutely. I mean, again, eBay is a big company. We have Ceph as well. I mean, we use less Ceph on the object storage side. We use it more kind of, I mean, for I mean, either file system or block storage, I would say. I mean, the main decision, I mean, when we analyzed it in 2014, Swift was at a certain maturity back then, and that's how kind of when we started introducing them. I know kind of, I mean, Ceph has been doing a lot of catch up, and now it's I mean, I didn't try it, I mean, lately, but I've been reading that it's becoming, many of the features that were only provided with Swift now exist also on Ceph object storage or object storage solution. So definitely right now there could be a consideration, I mean, for Ceph.
Other questions over here?
So you had mentioned the few previous object storage you'd gone through. Right? I'm just curious, how much of that was planned versus reactionary? Like, was it not meeting your needs?
Fair question. So again, one thing, I joined eBay in 2014 when we introduced. So definitely many of the elements I presented, I got some historical from the team that was there. I mean, my understanding, I mean, at some point, I mean, from the team, especially when they introduced the eBay picture service, at some point, I mean, they had a really huge issue in terms of scalability, and the site was growing, the demand was growing, and they didn't know how to handle kind of, I mean, this huge growing amount of data storage. And that's kind of, I mean, where they discussed and they had kind of, I mean, I felt, yeah, I mean, at that point it was, oh, okay, I mean, how we can solve it, I mean, right away. Then Atmos was introduced right after. I mean, again, it was the early stages of object storage, right? I mean, back then, 2007, AWS S3, I mean, was in a beta also, you know? So it was very, very early stages. Now I mean, then there was basically planning, and zStore was definitely created out of a planning and visionary or kind of, I mean, vision in order, oh, okay, I mean, we want to definitely solve the problem the right way, and that's how zStore was introduced, and we were able to get kind of, I mean, to move away from the eBay picture service. And also, I mean, discussing further, I mean, with Atmos, we had kind of, I mean, many issues I didn't describe or talked about here. But also, I mean, when we introduced Swift, it was about, okay, the next object storage solution, and definitely we want to move away from Atmos related. And we were able to achieve that, I mean, a few years ago. So.
One more question, somebody? No? I think it's good.
Thank you. Thank you, everyone.